Hi guys! So, welcome again sa second part ng ating problem solving for pressure in static fluids. So, part pa rin to ng ating course for fluid flow or fluid mechanics, no? So, today magsosolve ulit tayo ng mga problems. And this is just the second part kasi may mga susunod pa tayong problems na sasagutan para dito sa ating topic na pressure in static fluids. So, simulan na natin with this problem. A pressure gauge 6 meters above the bottom of the tank contains a liquid reads 90 kilopascal. Another gauge, height 4 meter, reads 103 kilopascal. Determine the specific weight of the liquid. So, ito yung ating illustration, no? So, ito yung bottom ng ating tank. So, sabi dito sa unang sentence natin, a pressure gauge 6 meters above the bottom. So, ito yun. From here up to here, meron tayong reading sa ating pressure gauge na 90 kilopascal. And then, another one, 4 meters from the bottom, we have a reading of 103 kilopascal. So, yung height nila from this gauge to this gauge is equal to 2 meters, no? Dahil 6 minus 4 is equal to 2 meters. So, ang required natin dito is to find ang ating specific weight. Okay? So, nalaman natin from our previous lecture that P2 minus P1 is equal to gamma H, which is our specific weight times the pressure head, no? So, since ang hinahanap natin dito is itong ating specific weight, so isolate natin siya. So, we have P2 minus P1 over H. Okay, so substitute na natin yung mga values natin. So, our P2 is equal to 103 kilopascal minus our P1, which is 90 kilopascal, okay? So, our unit here is kilopascal, di ba? And para mas maging clear ang ating unit, we know that 1 kilopascal is equal to 1 kilonewton per square meter. Okay? So, this is over our height, which is equal to, ito ang ating height, no? Between our P2 and P1, this is equal to 2 meters. So, we have here 2 meters. So, ano magiging unit natin, no? Cancel ang ating kilopascal. So, we have kilonewton per meter squared divided by meters. Our unit will be kilonewton per cubic meters, no? So, therefore, our specific weight is equal to 103 minus 90 divided by 2 is equal to 6.5 kilonewton per cubic meter. And this is our final answer for this problem. Okay, so let us now proceed to the next problem. If a pressure at a point in the ocean is 60 kilopascal, so let's say we are talking about this point here, no? And the pressure here is 60 kilopascal. What is the pressure 27 meters below this point? So, 27 meters below, ang pinahanap sa atin is kung ano yung pressure dito sa point na to. So, sinulat ko na rito yung specific gravity ng ocean or ng salt water, which is 1.03 dahil kakailanganin natin to sa ating calculation, no? Okay, so we learned from our lecture that we have for pressure variation, we have P2 minus P1 is equal to rho G H, no? So, this is our working equation. We have here specific gravity. Therefore, imumultiply natin yan sa density ng water para makuha natin yung density ng ating ocean or salt water, no? So, ang density ng water is 1,000 kilogram per cubic meters, no? And then, given din ang ating height, which is 27 meters. So, gamitin na natin yung ating formula. So, P2 is equal to the specific gravity of the ocean times the density of water, okay, times the acceleration due to gravity times height plus our P1. Okay, so yan ang ating working equation. Okay, so substitute na natin yung ating mga values. P2 is equal to specific gravity 1.03 times the density of water, which is 1,000 kilogram per cubic meters, times the acceleration due to gravity, which is 9.81 meters per second squared. Okay? And then, ang ating height, which is 27 meters. And then, i-add natin siya dito sa ating P1, which is 60 kilopascal. So, dapat pareho ang ating unit para may add natin siya, no? So, what is our unit? So, check natin ngayon. So, we have here kilogram meter second squared, which is Newton, no? And then we have meter divided by cubic meter, which means we will have a unit of Newton per meter squared. So, this is equal to Pascal. So, we cannot add kasi this is in kilopascal. Therefore, kailangan pa rin nating i-convert yung Pascal into kilopascal. So, that means I will have here 1,000 Pascal to 1 kilopascal. So, our unit here will be in kilopascal. Therefore, our P2 is equal to 1.03 times 1,000 times 9.81 times 27 divided by 1,000 plus 60 is equal to 332.82 kilopascal. And this is our final answer for this question. Bago tayo magpatuloy sa ating discussion, we would like to ask for your support by subscribing sa ating YouTube channel. Please click on the notification bell para lagi kayong updated sa mga videos na ipopost namin. Okay, so punta na tayo sa ating last problem for today, no? Okay, so the weight density of the mud is given by the equation gamma is equal to 10 plus 0.5 H, where gamma is in kilonewton per cubic meter and H is in meters. Determine the pressure in kilopascal at a depth of 5 meters. Okay guys, so one thing that we need to understand is that since our gamma is in kilonewton per cubic meter, once we multiply that to our height, which is in meters, so our answer will be in kilopascal, no? So we have to use this equation and automatically our answer will be in kilopascal, no? So now what can we see is that there is a relationship between our weight density and the height, no? So since the density of the mud varies with height, so that means we need to integrate our equation. So let us do that. So we know that our formula for pressure is equal to specific weight times the height. Okay, so first, since we'll be working with the relationship between our pressure and height, we need to take the derivative. Where our specific density here or specific weight is constant, no? So we'll take the derivative of P is equal to our gamma derivative of height. Okay, so I hope you are following with this, no? So, kinuha lang natin yung derivative ng ating equation, but our specific density or specific weight here is constant, no? And then we know that our gamma or our specific density is equal to 10 plus 0.5 H. So, substitute natin yan. So, we have dP is equal to 10 plus 0.5 H dH, no? And then we will integrate both sides. So dP will be integrated from 0 to P. And here we will integrate this from 0 meters to 5 meters, no? Okay, now we have here 10 plus 0.5 h dh. So the integral of dp from 0 to p is equal to p, and this is equal to the integral of 10 dh is equal to 10h, okay, plus the integral of 0.5 h dh is 0.5 h squared over 2, and this will be from 0 to 5. Okay, so substitute natin yan. So we have P is equal to 10 times H, which is 5, plus 0.5 divided by 2, 0.25 times H, which is 5 squared, minus 10 times 0, which is equal to 0, plus 0.5 over 2 times h squared, which is 0 squared. This is also equal to 0. So our P in here is equal to 10 times 5 plus 0.25 times 5 squared will be equal to 56.25 kilopascal. So this is our final answer for this problem. Okay, so in our next video, we will start calculating yung ating pressure variation kapag meron tayong different materials. Like for example, we have water below an oil. So kukunin natin yung pressure differences even though magkaiba yung mga fluids natin. Well, that's it for now, guys, and thank you for watching. We are inviting you to register sa www.engineers.org. It is a community of Filipino engineers, engineering students, and STEM students. Thank you very much and have a nice day.